Hello everyone, today I will be talking to you about forces in equilibrium. So now it's more about vectors, forces, sometimes we need to use trigonometry and stability as well, okay? So to start off with, first we need to think about that we have different physical quantities. So we may have scalars or vectors, okay? If we have a scalar, it has a magnitude, so that means it has a number, okay? And examples of scalars are these ones that I have in here. So number 11, number 6.32, 0.1, minus 5.5, okay? And speed and distance, for example, are examples of scalars because they only have a number. I can also have vectors. Now vectors have a magnitude and a direction, so it means that it has a number and then it says where that number is going, okay? So for example, I have here several vectors, okay, and I'm saying the size of the vector plus the direction. So northeast, southeast, northwest, east, sorry. And examples of vectors are velocity, displacement, force, and acceleration. So a scalar has a number, a vector is the number with the direction, okay? So for example, when I talk about speed, I can say that I'm going 30 meters per second, but if I want to know the velocity, then I need to say 30 meters per second to the right, or north, or something alike, okay? So I need to give the direction. So some basics. So addition of vectors. So if you remember in physics, we have this thing called the resultant force. So it's the same here. So you have two vectors. In the first example, I have 4 newtons going to the right and 6 newtons going to the right. The resultant is going to have to be, if I add 6 and 4 together, because I'm adding them since they are going in the same direction, okay? So the resultant would be a force of 10 newtons. On the other hand, in the second example, I have 6 newtons to the right and 4 newtons to the left. So my resultant would be 6 plus minus 4. And it's minus 4 because 4 is in the opposite direction, okay? So the resultant would be 6 minus 4, which would be 2 newtons going into the direction of the biggest vector, okay? It doesn't matter what you decide to be plus or minus as long as you stick to it. So I could have said 4 minus 6, and then I would have a resultant of minus 2 newtons, and it would have to go in the same direction as where the minus was going. In my case, minus would go to the right, so minus 2 to the right, or sorry, minus 2 and showing the vector going to the right would be equally right, okay? There are more vectors that you can add, so you may not have them in the same line or in the same direction. When you do that, you have different ways of doing, and I have a video here which is not mine, but this guy explains the video quite well, or the vector addition quite well, so I'll put that in the description. But basically, if you have two vectors they are adding but they are not in the same direction, what you do is you get the head of one vector connected to the tail of the other, and then the resultant would be going from the tail of the first one to the head of the second one, okay? So here head to tail, and here tail to head. It doesn't matter, sorry, head to tail again. It doesn't matter, it still gives me exactly the same vector. It doesn't matter which I added first, okay? Another example, A going diagonal and B going to the left. So I get again A, and then the head of the A starts the tail of B, and then I get a vector going from head to tail, or tail to head in this case, A plus B, okay? And then if you have many other vectors, you keep doing it, okay? So I have A plus B and C all in the same direction as they were, plus D, and this is my resultant, okay? I know this is not super explicit, but there is actually this video that has the guy actually drawing the vectors, and then this may help you, okay? Now, there is a theorem that we are going to use quite a lot, which is the Pythagoras theorem. So what he says is, imagine that I have a triangle, and as you could see in the previous slide, sorry, let me just go back here. I have here, sometimes when I add vectors, I may get an angle of 90 degrees, okay? So when I have a triangle where I have one of the sides of 90 degrees, I have a relationship, or I have a way to figure out the number of one of the sides. So how big one of the sides is, if I know how big the other ones are. Okay, I'll tell you the relationship in a second. So imagine that I call this side A, the adjacent side, this side B, the opposite one, and that I call C, this one, the hypotenuse. Okay, the relationship that Pythagoras figure out is that C squared, so hypotenuse squared, is equal to A squared, the adjacent one, plus B squared, the opposite one. Okay, so in general, if I have two perpendicular forces, the resultant force, if you think just about adding vectors A and B, the resultant force is going to be the square root, because I would have here f squared equals f1 squared plus f2 squared. If I want just f, I do the square root of this adding up together of f1 squared plus f2 squared. So the resultant will be the square root of the adding of the two vectors squared, and the angle, theta in this case, between the resultant force can be given by the tangent. Remember that tangent is going to be the adjacent angle over, the opposite angle over the adjacent. Okay, so sine is opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and then opposite over the adjacent is going to give me the tangent. Okay, so this way I have the magnitude of the vector, okay, or the resultant force in this case, and I have the direction, because I can say the angle that the vector is going. Okay, so more maths is more or less what I just told you, but now as an application. So here I have force 2 of 7 newtons, force 1 of 10 newtons. They have 90 degrees between each other, so they are perpendicular to each other. If I add them together, I get this resultant force F. Okay, I know this is 90 degrees, and I have here an angle theta, so I may want to know what theta is equal to. All that I need to do is work with Pythagoras' theorem. So F is going to be one of them squared, so 10 squared, plus the other one squared, 7 squared, and then because I want to get to know F and not just F squared, I do the square root of it. Okay, so this would be the number. You can do the calculation to check what this is. And then if I want to know the angle that this, so I have the magnitude so far, right? If I want the angle, so the direction of my vector, I'm going to use the tangent. So I'm going to use the opposite one divided by the adjacent one. So I have 7 over 10, and that's going to be the angle in between the resultant and the initial direction in this case. All right? So that's a worked example. So if I want to resolve vectors into components, I can always say that I have a vector and I can make it into the y and the x component. So the horizontal for x and the vertical component in y. Okay, so fx can be my horizontal component, fy can be my vertical component, and f is my resultant vector. Okay, so using again Pythagoras, I can say that my f is going to be the square root of fx squared plus fy squared. My fx can be related to f by saying that is going to be equal to f times the cosine of the angle. Remember, the cosine is the adjacent over the hypotenuse, so the adjacent is the hypotenuse times the cosine of the angle. Think in the same way, fy, sorry, I just had a hiccup. Fy can be f sine of the angle, because again, sine is the opposite over the hypotenuse, so sine would be fy over f, so fy will be f times the sine of the angle. Okay, so we can do examples, or we can do exercises such as this one. So I have this paraglider. He's going to be pulled at a constant height. Of course, this doesn't quite happen, but let's assume he's at a constant height. He's being pulled by this boat, and the angle that he's being pulled on the rope is 35 degrees to the horizontal, so the x component. Okay, they say the force that he is being pulled is 500 newtons, and they say, as I just told you, at an angle of 35 degrees to the horizontal, and then they say calculate the horizontal and vertical components of the force. Okay, so that means that I'm going to have Fx here, and I have Fy here. Okay, and this is my F, my force. So I will just use Pythagoras just as I did before. Okay, so Fx, the horizontal one, is going to be F times the sine of 35, which is the angle. So 500, the resultant force, the total force, times the cosine of 35. This would give me 110 newtons horizontally to the right. Look that I'm saying the direction of the vector, okay? And then the other one, so the other force that I have in here, so it's going to be the opposite angle times the sine of that angle. Did I say it right? Sorry. It's going to be the hypotenuse times the sine of the angle, because I want the opposite angle, sorry. So it's going to be 500, the total force, times the sine of 35. This would give me 287 newtons. And again, you need to say the direction of the force. So if you want to know the forces in here, I would have this force pulling him down, okay? So he's here, and it's going to be vertically downward. So I have one force in here, one force in there, okay? You could have done just like this as well. So the forces are the same, Newton's third law, okay? So I hope it's I forgot the word. I hope this is clear for you, and I'm going to go more on forces in equilibrium, and you know, once I do this whole chapter, I'll make it into a playlist so you know how to get all these things together. So if you have any problems, do let me know, write me a message, and stay tuned for the next video, which probably will be astrophysics. Bye, see you. Let me turn this off. Bye.